All right, so you have a stepper motor, and it looks like this. And you need to make a plate, like a face plate, a bracket. You're going to screw this motor down. You want this motor not to move. You want to be able to screw it down to something. How do you do that? Well, first you need to know, how much room, how big this thing should be, right? So you should measure how wide it is, and then how far from this hole to this hole. I recommend you do that with dowel calipers. I also say that you can do this. I searched bolt pattern on NEMA stepper. Do not always trust these charts. Double check them with a dowel caliper. If you're really close to these numbers, and these numbers are probably the exact ones. So if you look at the bolt pattern right here, it says A, and let's see if I can zoom in for you guys. This is A right there, and that's from here to here, right? Which is from here to here. It's also A, it's the same thing. And A is right here. And I think we have a NEMA 17 or it's a 14. I think it's a net 17. That's definitely the most common one. But if that's the one, it's 1.22 inches from one to the next. What does NEMA 17 mean? 17 is the motor size, or what's called the faceplate size. So this entire faceplate, DD right here. You see this DD, it says DD right here. That's all the way to the top, all the way to the bottom, or from the right to the left, the whole entire plate. The holes, however, are a little bit smaller than that, in between anyway. So let's go ahead and start doing that. So let's create a document. We'll call it stepper bracket. And this is, here we go. And so I'm going to go ahead and sketch the faceplate on the front plate, or the front plane, sorry. And I'm going to start, everything if you can do from the center works great. For example, I'm going to get a rectangle and say center rectangle, because I'm going to assume that this is like where the shaft comes out, and it makes it easier later on for bolt patterning around a center point if that's the shaft of the motor right there. Okay, so we know the entire faceplate is on a NEMA 17, assuming that you have a NEMA 17. I don't know what you have. You want to look it up. So this is the entire faceplate. It's 1.7 by 1.7. Okay, so that's the entire faceplate. You can make it bigger than that though, if you want. So this will make it where this is the exact size of your stepper motor. Okay, and let's go ahead and extrude that out. And for me, I'm going to extrude this really thin. I'm not going to make it very thick here. So I'm going to make it like 0.05, and we'll try to strengthen it later on. What else do we need to know? Okay, we need to make those holes, right? Definitely. So we need to make this this distance A right here. Look at D right here. It says pilot diameter. So there is a diameter, this little circle in the middle. They're not showing that circle here, but I think they're talking about that here. Again, you have dowel calipers. Go ahead and measure it. How big that circle is. There's this like little puffed out circle that comes out right here. You can see it actually right here and right here. It just comes out a little bit. How far? It comes out E, which is pilot depth on a NEMA 17 is 0.079. So actually, I think I'm going to go with making my material that thick. I think that'd be cooler, so that the metal's almost flush. So I'm going to round up a little bit, 0.08. So I'm going to go back to my extrusion right here and just make it 0.08. I think that'd be really cool if the stepper motor, because otherwise it would hang out a little bit, and it should be totally flush to that. So that's kind of cool. All right, let's sketch the front of this, and let's get to it. So I'm actually, let me make sure I'm doing the right side here. Sketch this side. There we go. I'm not sure if I clicked the wrong side. And I'm going to click this thing again, the center rectangle, and click here. And I'm looking for this bolt pattern right here, this A right here. Bolt hole distance on a NEMA 17, 1.220. So let's do that. 1.220. 1.220. And I'm going to make this entire square. How can I select it? I got to push escape. I'm going to click all these lines. I don't need this square itself. Like, I'm not going to build a square. I just need it to come up with these four corners. So I'm going to make it all construction. In other words, I don't want to be able to mess with it later on. I just need it for a guide for these corners. You could probably use a pattern feature for this. For me, it's only 4 holes, so I'm just going to go ahead and do that here. I don't know if it says how big those holes are, but once again, you have a dial caliper. You can measure. Here's the diameter of G, bolt size hole. It is, a NEMA 17 is a 440. Interesting. I always thought it was like an M3 screw. So 440, what is that? You can go 440 screw size, screw diameter. There it is. That's the screw is this. So I'm going to round up a little bit to like a 13, I guess, 0.13. So make sure it's a little bigger, just in case, you know, I don't want to be fighting with it later. 0.13 and 0.13. And obviously, I'm just going off of charts and on the internet. I don't have one in front of me. If I had a stepper motor in front of me, believe me, I would measure it, because you know how long it takes to 3D print something, right? I don't want to sit there and 3D print all this, design all this, because I assumed it was all this when I literally have in class a stepper motor. I have a dial caliper. I could just measure this real quick and double check these numbers. It takes me 2-3 minutes to do that. And then I'm not wasting hours printing and days printing and then coming back and it's not the right fit and stuff like that. So just measure it. You got it in front of you. Just double check that you're really close to these numbers. All right. So check mark. Let's make those holes. So extrude. We're going to click that hole, that hole, that hole, that hole. Notice the square, I can't click it because it's a construction line. And that's kind of what I wanted. I didn't want this to like extrude 3/4 of a circle. Then I have to click that little corner right here. You know, you could do that. It wouldn't be a big deal, but why do that? Okay, so remove. I'm removing those holes. Done. So I got the bolt pattern. Now let's sketch and let's do that big hole in the middle for the circle, for the shaft and everything. So you could just make a little tiny circle big enough for the shaft, like even smaller than that. But you have this big circle right here, I'm pretty sure, that sticks out. Remember, it's this, you can see it right there, this circle. I think all stepper motors have those. And this one is D right here, which for a NEMA 17 is 0.866. So let's go here, 0.866. And like I said, if you don't want to fight this later on, you know, do 0.87. Make sure it's just a little extra wiggle room there where you're not trying to fight it and going, man, I got to sand it now because it's like too tight. I did the same thing. I made those a little bit bigger too. All right, so then just click this and extrude and remove, and you're done. And that's it. That's your faceplate. Now, of course, you need like a piece of plastic down here so you can say sketch this. And I'm going to show you something real quick. Here we go. And I'm going to choose corner rectangle, this corner one. So not the center rectangle. So I can click this corner and click here. And how thick am I going to make this? The same thickness as my other part, which was, I think, 0.8 is what I went with. Oops. 0.8. There we go. Oh, no, it was not 0.8. It was 0.08. There we go. And then I'm going to extrude. And I'm going to put this out like, I don't know, 1.7 inches. I guess just like the other side. If you want, it could be shorter. It doesn't need to be the same length. Now this is going to be really weak right here. I mean, it can break on you. You know what I mean? Because it's just barely held on this little spot, 0.8 inches thick. So I'm going to create another video on how to move this. Also, we have to fix something right now. Your motor is not going to fit here. I just wasted space right here on this big plate. We made it exactly right. I used space for this plastic part. So now your motor's not going to be able to sit down low enough. This is going to be in the way. So we got to figure that out. So let's do this over here. Let's go to this original sketch and let's create this and go, I don't know, 1.8 bigger, and that should be good. You can actually go a little bit more than that because I just realized it grew up more as well, and because I did the center one, that's why. So I'm going to go a little further, 1.9, and that'll make sure it's safe. I grew 0.1 inches this way and 0.1 inches that way, which is more than enough. And there you go. And that's going to be enough room now down here so that the motor can sit low enough. Otherwise, this plastic piece I did got in the way. So the next video, I'm going to show you how to add wings right here. But to do that, just to let you guys know, you're probably going to need to add a little bit more width then, because now you're going to add wings on both sides, or what they call ribs. Ribs that kind of connect down and make it stronger, okay? And that's it.